Hello, everybody. Welcome to our Data-Driven DevOps webinar. Today, we are going to talk about what is data-driven in the context of DevOps, what should change, how it should work, etc., etc. I hope you can see my screen, and I hope my presentation is working. Yes. This is me. My name is Baruch Sadogursky. I'm the head of developer relations with JFrog. You can follow me on Twitter on JBaruch. And if you happen to discuss this webinar on Twitter, we have a special hashtag for it, Data-Driven DevOps. I'm coming to you live from Seattle, Washington, from KubeCon 2018, where a lot of discussions are about data and how to be data-driven. So it's kind of everything matches together. And before we dive into interesting topic of cobbler's children have no shoes, let me just go through a couple of housekeeping items. So all of you are on mute to ensure audio quality, but it doesn't mean that I don't want to hear from you. There is a Q&A button on your Zoom control panel. Please use that to ask any questions you might have. We will have some time in the end of the webinar for Q&A, and I will take as much questions as I can live. For more like technical questions or comments not related to the content, there is a chat that you can contact us. I don't know if audio doesn't work or something like that. But the questions, please keep them in Q&A. It will be easier for me to track. As I already mentioned, this webinar is live on YouTube. So you can go to JFrog YouTube channel and get the recording right after we end the webinar if you want to watch it again or share it with your colleagues. And also you will get a link to it in the follow-up email that we will send in a couple of days. So with that, let's talk about which children don't have shoes and why. So I want to start with the poll. I hope to make it as much interactive as possible. So let me just find the right poll, this one. And here we go. Very simple question. If any of you are a software engineer, are you an optimist? And do you know what are you doing? And that's obviously multiple questions. And let's just give it a couple of seconds. It's not a really serious question, so the results here or whether all of you voted or not doesn't really matter, but by all means, go ahead and vote. Well, you know what? It's good enough, really. So let me share the results with you, and I will read them out loud for our YouTube audience. Well, the majority of you are software engineers, the majority of you are optimists, and the majority of you know what they are doing usually, which is absolutely normal, right? Obviously, the audience for this webinar are software engineers, and software engineers are optimists. And that's because our domain is hard, annoying, and frustrating. So without us believing that it will get better, I don't think any of us will actually could make their job, and that would just bring us very fast to clinical depression. Also, we know what we are doing. We are all professionals, and in our daily job with a given task, we believe we are capable of performing it well. So there is no surprises in this poll result. And the problem is that although those two features, as I mentioned, are great because they allow us to keep up with our job and actually usually do a great job, there are some problems. So first of all, optimism is an illusion, right? We think that everything will be good because we deal with it. we have some kind of superiority, and we think that we are smarter than we are, and that allow us to keep going. Again, it's a good thing, because otherwise, clinical depression. The problem with our self-confidence, the problem that we come every day to work and we think we know what we are doing, is that it brings us to the second system effect. When while we did something right once, we are pretty sure that the next task will be as successful as the previous one, and it actually brings to an over-engineered bloating systems due to inflated expectations and overconfidence. And again, this is completely normal, but this is it. And this quote is obviously from the great book, The Mythical Man Month. If you didn't read it, I highly recommend it. It's like software engineering, one of the software engineering classics. Well, so those two illusions, those two paradigm that we work under bring a couple of consequences. The first is this. That's a Venn diagram, and that's one of my favorite slides of all time. I hope you correlate to it as I do, but the more I know about software, even the one I really love using, the less I like what's going on inside. As people say, I'm too close to the manufacturing of sausages, and that kind of ruins it for me. The problem is that with software engineering, everything are sausages. When you look under the hood, most of the time you are completely horrified with what's going on. Another problem is this. Again, I bet you all relate to it. Every software is 80% ready 80% of the time. Me personally, that's my constant state of mind. I do some home improvement projects for fun over weekends, and one of them was a ridiculous demonstration of this one. I worked on some project, and my wife asked me once in a while how it is going, and I constantly replied, "I'm done in 2 hours." And this "I'm done in 2 hours" went along for a long weekend, for 3 days. But for entire 3 days, I was 80% ready. I was like 2 hours away from done. And that's, that's the same. That's the optimism. That's the self-confidence. I know what I'm doing. I'm almost there. Another consequence is the sunk cost. It's very hard to give up on something because it's 80% done. I'm almost there. Why would I give up all the hard work that I put into it when I'm almost there? Right, and I think that what I drive is we really don't know what's the real situation with what are we doing, and this is where data can help. So this is an example, and this is obviously data. This is an example of an analysis of customer defects. For a project that a big friend of mine, Leonid Golnik, at the time, VP of engineering in a very, very large software vendor, did for one of his projects. And those are the numbers. You see what I see. There are 65% severity 1 and severity 2 defects. And let me ask you something real quick. There you go. What do you think about the quality of this product? Again, that's not a real serious poll. I just want to see if, what do you think about it? And obviously you're a smart audience, so you go to the last option of it depends, and that's funny, and thank you for that. The majority of you actually answered it depends, which is the right answer. But just to entertain the idea, it looks like it's a bad project. it looks like we do have a problem here. 65% severity 1, severity 2 clearly demonstrates a problem with quality. And that's kind of a teaser of what we are going to see through our webinar today. And I'm going to get back to that. So thank you for that. And you all know what this picture is. This is a stand-up meeting, like a standard Scrum, Agile, Kanban stand-up meeting daily. Every morning, people get together and speak about what they achieved, what the progress is. You can see some some stickers on the board that doesn't look exactly like Scrum and Kanban, but you know the setting. The setting should be familiar to you, and this is a good process, obviously, but it has some problems. Let's talk a little bit about how different departures measure what they have. So sales have their own systems, like most of the organizations have Salesforce. They have the numbers there, they have their progress there, everything sales related. Marketing have their own systems that could be Marketo, that can be Prodot, that could be other different systems, but they have, so we know exactly how many, we as marketing know exactly how many people came to this webinar and basically how did you learn about it. So we have strong numbers. Support, they have their own systems, Zendesk, Freshdesk, Desk.com, Salesforce Help Desk, or whatever. And again, they can track and know numbers. Finance, obviously, those guys invented numbers, so they have NetSuite, they have their own tools. HR, Workday, Oracle Taleo, whatever. And what do engineering have? Engineering have anecdotes from daily stand-up, because this is how we measure, this is how we collect data. We come together, we talk about stuff, and then we're like, yeah, we are 80% done. And obviously, keeping in mind how defected our thinking is, how over-optimistic we are, how overconfident we are, those anecdotes from the daily stand-up are not really reliable. And since everybody knows that they are not really reliable, no one really even refer to that. So the rest of the departments have a healthy conversation with numbers, right? So sales can go after marketing. You don't give us enough leads. Here are the numbers. Marketing can go after HR. You don't give us enough headcount. Those are the numbers. And then kind of R&D are in the corner with their anecdotes from this daily stand-up, and no one really takes us seriously. And sorry about it. And this webinar is about how we change that.
And we aren't really making the decision. The data is. So you hurt our friends' feelings without taking any responsibility? Me likey.
Yeah, so if you like it and I like it, the idea that we need to bring data into conversation, let's see how we do that. It's not that metrics did not exist in the pre-DevOps era, even in R&D. Obviously, every silo of our DevOps had their own metrics. For dev, we had velocity and architecture complexity and compliance. We're going to talk about velocity a little bit very soon. For ops, obviously the SLA, the time up, but also cost of environment setup, average customer cost, tool chain stability, and QA also had their own, still have their own metrics, like the number of incidents, the number of defects, mean time to recovery, code coverage tested, etc., etc. So we had those metrics. We might not use them enough, but they're there. And the difference is, what is the metric that we should migrate when we talk about DevOps. What is this magical metric that is the success of DevOps? And we can make the analogy of this one magical metric referring to velocity for Agile. So velocity is the main metric for Agile, obviously, and you all know that. So what is this main metric to DevOps, as velocity is the main metric of Agile? And I would argue that this metric is profit. Or for non-profit organizations, obviously, how do you call it? Being effective, right? And this is a good metric because it's actually what DevOps is about: delivering better software for our customers and users in less time, so they will use it more. And obviously, for a commercial company, they will pay for it more. Uh, and it is a good metric like velocity because it's very easily understandable, right? Either you make more money or you make less money. Either you have more happy customers or you have less happy customers. And it also provides unity because everybody can rally behind this metric. We are doing great, we are not doing so great. Those are very, very clear metrics that provide unity and clarity. Another poll, and this time it will be about, where is it? Velocity. Remember, I told you we will get back to velocity? Let's get back to velocity. So, check everything that applies. If you know what velocity is and you have the burn down chart, select both. Oh, I see a great comment from Michael that velocity junk math. Um, Thank you, Michael. But we're going to get to that. But first, let's see if people use it. Okay, I think I got kind of a little bit what I wanted. It doesn't look exactly the way I expected, and obviously most of my polls are kind of staged to see the results that I want to see. This one didn't exactly look like I planned. What I wanted to show you that the majority of the people know what velocity is. This is true. The majority of people know what the burn down chart is. No one voted. I'm not sure if you don't know or if you just missed this question. And then as we go with working with the burn down chart, less and less people use it, trust it, or knows what to do when it doesn't look right. And this is kind of, for me, the main problem of velocity. It's great when it's growing. People are, we're moving fast, good job. But when things go bad, people don't really know what to do. What the problem is? Do we have a quality problem? Are there not enough people working on the project? Maybe it's too much people working on the project. Maybe if the requirements are not clear enough. Maybe it's just a very hard software problem to solve, and we have a hard time. So for me, the problem with velocity is that it is the same with profit. It's not very, what happened? Yes, it's not very actionable. And what I mean by that is that what are we doing if the velocity is going down? It's not clear. As it's not clear what are we doing if the profits are going down. Maybe the profits are going down because there is stagnation in the market. Maybe the profits are going down because we don't know what to sell our great product, or maybe our product is not great enough. There are too many options because the metric of profit and the metric of velocity is too coarse. And that brings me to the wrong question that I asked in the beginning. What is the main metric of DevOps? And the error is that if we treat DevOps as a one very coarse concept, it's very hard to come with the one very coarse metric. In the reality, DevOps is still those three different disciplines: the dev, the ops, and the QA. Well, unless you are Netflix, and most of the people are not Netflix. So we do have common goals. We do have common tools and common culture, but our deep specialization still exists. We still have this deep specialization, and the difference with DevOps is that now everybody talk with each other. Now we have this collaboration, and it's absolutely the same for metrics. We still have common metric, which is doing better, and we have those specialized metrics for each and every of the domain of DevOps. And of course, as with everything else, the key is that those metrics have to collaborate, have to talk with each other, influence each other, etc. And they do collaborate, and I will give you just a couple of examples here. So I have this table, this matrix of who influenced the metrics and who are affected by metrics. And here is an example. Metric, some metrics that are clearly influenced by ops, time to build. Let's say if the ops team set up a proper artifact management topology, and they have artifact repositories in all the development locations, and they are set up with proper replication, the dependencies will be closer to the CI toolchain, and the build will be faster. Who is affected by that? Obviously the development, because they expect rapid feedback, they need faster build. So this is how ops, a metric which is influenced by ops, affect the development team. Release pipeline stability, same here again. If we have critical pieces of our pipeline failing, the CI server, the artifact repository, they are not highly available and they go down, it's the stability is influenced by the ops team. They didn't set up HA properly, and obviously dev are suffering and affected by that. And I mentioned the artifact replication topology. Another example will be metrics that are influenced by QA. So false reopen count. If QA keeps opening tickets which are not defects, which are not bugs, obviously it slows down the development, right? So another example would be something that a metric that is influenced by dev but affects ops, and that will be average cost of customer. Think about how a well-written code can reduce the amount of hardware that it's needed to run it. That a direct influence over a metric which is traditionally with the ops, how much money I spend over a customer. Another one here is smoke test quality. This is a metric which is influenced by QA, but affects ops because this is what decides whether we're going to roll out a new version or not, and the other way around. Influenced by dev, when development writes bad quality code, obviously QA are suffering because they now have to work much more, and the speed in which they can test versions and test new software is reduced. The same with ops. If it takes forever to create a new QA lab, obviously that's something that ops take care of, and it affects QA. So now, instead of having these silos of metrics, I only care about my thing and I don't care about anything else. So let's say here when in the case of average cost of customer, the development says, okay, I fulfilled the functional requirements of my code and I don't really care how expensive the hardware is needed. And then that will be like a silo. They don't care about ops. Now we actually all in it together. It's DevOps now. So Dev and Ops will work together in improving the code in order to reduce the average cost of customer. Those are obviously only the examples. There are much more. We will see some examples soon. The second part of this webinar is what I call cooking with metrics. And I will give you some concepts and some examples of which metrics matter and why. So let's start with metrics categorization. Let's talk a little bit about what metrics exist and why we even collect them. And the first category of metrics is understanding why we measure it all. And there are at least three reasons. The first is, are we doing the right thing? In order to decide whether we should do something, we need to understand, is it the right thing to do? Why people are standing in a line for this restaurant and not another? And that's obviously first McDonald's in Soviet Russia near the Red Square in Moscow in 1989. My sister is somewhere there in line. Obviously, this restaurant does something right. What is it? How do we measure? The other is continuous improvement. I want to compare this activity to another same activity that I did in the past or I plan to do in the future and see if I'm doing it better. So is this webinar is better than the previous webinar I did last week? So that's another reason to measure. And the third reason to measure is building trust. And this is very important because this is what makes the DevOps collaboration possible. If the ops can trust the dev to write the best code possible, then they know that dev does whatever they can to reduce the average cost of customer. And we're going to talk about all three of those now with some examples. Another very big question is, what do we measure? How do we collect samples? And there are a couple of different options. The first is complete samples. As this young lady, when she's shopping for her oranges, she will probably check each and every one of the 8 oranges she picks up to check that they all flawless. Obviously, having more data is generally better than having less data, but first, it's not always possible, and second, it's not always needed. So complete sample is needed when you measure the return on investment, right? So sales are expected to record and measure every sale they make, because this is how we determine whether we should make any changes in what we are doing. But others, for other types of metrics, other types of sampling is required. We are going to get to that. Now, what you see here is a very complicated, obviously, tool that is very good for measuring, but it's very hard to understand, and it is Microsoft Excel. And what you see here is another example of real-time data from engineering effort allocation in one of the sprints of a real product. And this sprint was designated to creating a big feature A. And if I'd ask you what is the allocation for creating new work, for writing new features, for this, or for writing new code for the big feature A, I bet you would tell me something around 50%. You expect a team to work on the big feature of the sprint around 50% of the time, spending another 50% on ongoing maintenance, on fixing bugs, on fighting technical depth, and the rest of it. But when you gather the data, when you do the complete sample of where the effort went, you discover suddenly that only 13% was invested in big feature A. And this is very disturbing. But you didn't know it until you sampled everything, and then you have this, and only then you have this picture. Another type of sampling is representative sampling. When you actually don't collect all the information, you collect only samples of that. And there are types of measurements for which representative samples are enough. For example, when measuring how effective are we, when measuring for continuous improvement. Samples are good enough for that, right? So I will ask you in the end of the webinar, how did you enjoy this webinar? And some of you will vote and the others won't. But assuming whoever voted, voted representatively of all the rest, that will be enough for me to understand whether this webinar was better than the one that I did last year or actually no. The trick is to collect this over time. If I didn't ask you last week, I have no data to compare. So it is, representative sampling is good if it's collected over time, and it is useful for measuring how effective are we, or for continuous improvement. The third, the most complicated type of measuring is predicting the future. For predicting the future, we actually need both. We need to collect all the data, we need to do it over time, and then we can extrapolate. Obviously, predicting the future is always hard because there are so many factors that can weigh in and mess with our predictions. But if you need to come up with a result when a certain feature will be ready, you need a trend which is collected, which represents the much data as possible, right? So that's a combination of it. Let's talk about some examples. And for examples, we will use Scrum Team Avengers. If you're a fan of Marvel Cinematic Universe as I am, you will relate to it, especially after the teaser of the next Avengers movie that was just released. So let's hear what those guys have as anecdotes from their daily startup and see how data can support or not support it. Right. So the first anecdote is we never get enough testing environments from ops. And that's obviously the people who are concentrating on quality in our team. They want to establish some pipelines to let us to check the software, and they need environments for it. Whoa, that was okay, Google. I hope I didn't trigger it again. Oh, okay. Sorry about that. Yes, so they need those environments, and they're we don't get them enough. That's a problem. What do? We obviously measure. So what you see here is we sampled all the data, and now we know that there is truth in their assumption. We have 10 environments, and most of the time, all those environments are completely utilized, like fully booked. Yeah, there is a projection there that looks like there are some available, but it's just, it's just a projection. It's actually fully booked more of the time. So they are correct. Now, the reason is why. And to understand why, we need more data. So we can ask how many days those environments stay checked out. And what we discover here is that most of the people on the team never surrender their environment, or surrender it very rarely. They check out the environment and they keep to it like what, 2 weeks. It's kind of understandable because they expect not to get new one anytime soon because they're all busy, but it's still obviously a problem. So how do we improve based on this data? First of all, as responsible managers, we will provision more environments. And this is this peak. Those environments will be utilized immediately because more people will just check them out and never check in. But then we can implement a very simple trick of auto checking. We'll send an email, look, your environment was checked out for 24 hours. If you need it, confirm here. If you don't, we will check in automatically. And what we see here is that not only the problem we solved, we actually managed to save some money. From those 10 that people start complaining about, we actually managed to cut it to 8 because with auto checking, that's enough. So we gather the information, we analyze the data, and we act upon it. Another anecdote is, for example, tests are failing because the test suite is not stable. QA makes our builds fail without reason. There might be truth in it, there might be not. What we need to do when we have anecdote from daily stand-up, we need to collect data. That's example of how we created a new Jira type, tested stability, introduced it in Jira, and then every time the build failed because of that, we asked the engineers to select this as an option. And what we see here is created this result chart, which is very popular on Jira, that shows that yes, there is a problem. Look at how number of issues of this type skyrocketed. We understood that there is an issue. We started to fix it, and after what? After 2 weeks, as you see here, the graph stabilized. There is like 3 issues that we maybe decided not to fix or maybe take some time, but generally no issues of this type created, and that means that we managed to stabilize the environment, and this issue is now gone, which is return on investment, right? Eventually, we collected all the data, we act upon it, and now we know that we are in a better place. Another example is about trust, and as I mentioned, trust is hard to gain, and it has to be built on data. And here's an example. The ops people, the infrastructure, the tooling people of our Scrum team complained that the developers want to provision some new garbage collection, and the benefits are not obvious. The only way to deal with this kind of objection is coming with data. So we can set up a lab, we can stress test the new garbage collector, and you can see here that there are obviously some that perform better, some that perform much worse. So you can see here as Shenandoah garbage collector stands up and providing extremely low latency. So that was the recommendation of the development team. And what we can see here is that the trust paid off. And once the team switched to this new garbage collection, they had a dramatic decrease of latency and garbage collection time. And that's obviously a very big win. We're talking about a high load system here. So it was a good bet. And the only reason the team took this bet is because they had data for that. A little bit of do's and don'ts when you start collecting data and working with data. First of all, is measuring the right thing. And obviously here, the most ridiculous example in our industry comes to mind, and then measuring lines of code. This is obviously useless as a ridiculous metric, all of you understand it, but it's still a thing because it's very easy to measure. So here we kind of looking under the spotlight. We found something which is very, very easy to measure and to collect. And we're like, yeah, let's use that as a metric. And that's obviously a very, very big mistake. We need to measure what's important, not what's easy to measure. Another advice is really to avoid data overload. Once you start measuring, it's very easy to get into this mood of let's measure everything when actually not everything matters, and we just will start kind of diving into data without understanding what's going on. So again, that's avoid data overload. And another very important aspect is using the reliable data. We spoke about how representative sample is important. I guess going back to the poll of how did you like the poll, only if people who extremely like the poll, the webinar will answer this question, and people that weren't very pleased with it, just ignore it. I will have a distorted picture of what's going on. Another example is doing the right collection and gathering of the data to get reliable data. For example, if for some reason finance will miss half of the revenue recording, we will have a very unreliable picture of how our company are doing. It's the same with engineering. If only some engineers report what they work on, and it's not, and let's say they only work on the feature A, we will have a very distorted picture of how much allocated to feature A. So this is very tricky, and we really need to be very careful with that. Common vocabulary, and that's very important because, for example, getting back to our result from the beginning, what is severity 1, what is severity 2, what is medium in Brazil, what is medium in Russia. If people mark severity 1 and severity 2 and severity 4 and 5 differently, again, our data is not reliable. So it's very important to establish this common vocabulary before we start collecting anything. And another very important aspect is remembering that metrics generate incentives. And you can see here in, I guess, one of my favorite Dilbert comics, how wrong incentive of paying per fixed bug to the same people who can introduce bugs is obviously a KPI that generate incentive, that generate behavior that obviously is not improving anything, but the other way around. Tweaking as you go is important because collecting a lot of information, analyzing a lot of information is hard. And it might very well be that you need to switch from something that you measure to something else. And getting back to the example of the tested stability and how we fixed it, and there were no new issues, that will probably be a good time to stop collecting this information and look at, well, collecting, but stop looking at this dashboard every morning, just because chances are there are no surprises there. It makes sense to look at it once a month, maybe even once a quarter, but that's definitely not the dashboard you start the day with anymore, just because you need to move your attention to something else. And I think that brings me all the previous do's and don'ts, like collect only relevant data, avoid data overload, trust your data, and look at the right things, brings me to one conclusion, which is you need to try to elevate your perspective on the data. So there is raw data. There is going back to, for example, let's take builds. You can examine every build in your CI system. You can look at the output to understand whether, for example, all the tests have passed or there are some warning. But obviously, you won't do that because that's too much work, and you actually have a product-specific dashboard. If you go to a homepage of your CI server, being it Jenkins or anything else, you will see the trend. You will see how many builds are working, how many builds are failing, is there unstable builds, etc., which is a good elevation. But what we would recommend is elevate even more, because your CI server is only one step of your software delivery. And if you have a dashboard that gives you a bigger picture of the entire software delivery, that would be a good place to look. And since you are here in JFrog webinar, I will show you such a dashboard, which is a JFrog product. It is JFrog Mission Control, which have a component that we call JFrog Insight. It's part of Mission Control. And this tool not only gives you a dashboard of one of the aspects of software delivery, it actually gives you a view on the entire pipeline. And you can see here, and this screenshot, you can see information from your CI server, how many pull requests there are in, how many commits there are in. You can see information from your CI server, how your builds are running, how many of them successful, how many tests have passing. You can see here information from your artifact repository, and promotions is the critical part of it. How many builds actually were promoted from one environment, environment in your pipeline to the other, through the quality gates, and eventually to released. Information on how many artifacts were deployed or not deployed, and what is the build storage. That's the predictability we spoke about, how much money you need to allocate, and then eventually security vulnerabilities that you have inside your system. How many of them are critical. So what you look here is actually a graph of security vulnerabilities. So we have 27 critical and 3 medium in one build. So you see this graph of the vulnerabilities as well. So you elevate, you look at the dashboard, you get all the information from all the aspects of your continuous delivery. And with that, let's come back to our teaser from the beginning. And obviously, most of you said, well, it depends whether the 65% of severity 1 and severity 2 means big quality. And you were right, because if we are taking the next step in measuring data, we can slice the same defects by resolution. And when we slice them by resolution, we will discover that 52.3% of severity 1 and severity 2 were resolved by information provided to the support team, whether it is how to operate the tool correctly, or whether it's how to overcome a certain lack of features and this kind of stuff. But they weren't really defects that require code fix. Code fix was going to only 20%. And when we have this data, the entire conversation changes. When we look at the first graph here, it's obvious that what we are up to is a blame game between QA and development. The head of QA comes to development and say, the head of support, and say, look, your product is crap. Obviously, there are a lot of severity 1, severity 2. You need to fix it. And this blame game is completely removed by gathering more data, because now we see that the problem is not there. The problem is with how well the support personnel know the product and can successfully resolve issues or prevent issues. And it means that what needs to be done is to educate the support, and that will solve, of course, the majority of the issues much, much cheaper. And this goes back to the entire conversation, not only inside the R&D, but throughout the organization. Now, when we have data, for example, we know what's going on with our velocity because we measure and not because we listen to the interview, to the anecdotes from the startup. We can have part of this conversation. And we just had an example with support and R&D about the issue. But it will be the same with sales, it will be the same with marketing, etc., etc. Now we can have a seat of the table of the adults and not just playing around with anecdotes on the back. So one of the most important is that it is removing the blame game. And that goes back to the video of Sheldon and Amy that came up with a clever idea on how to remove the blame game when selecting the best man for their wedding. And it also removed the blame game between the R&D and the support. And obviously for the rest of it, when we speak with numbers, there is no blame game because the numbers show exactly what's going on. Building accountability and trust. When we say that we will deliver something in a certain point of time, it's not based on our flows like optimism and the illusory superiority. We actually can prove that a feature will be delivered in this time because we have the numbers to back it up, and creates common base for discussion where back in the table we can argue with numbers. So with that, we are approaching the end, and I will be happy to answer some questions that you may have. While doing that, let me collect more data from you. Aren't we data driven? So I really want to know what you want to see next as a webinar, and we do all kinds of, there are best practices using generative products, there are overview of new products and features, there are partner webinars, and there are high level and thought leadership webinars like this one. Uh, Let me know what you would like to hear more, and we'll obviously take that into account and try to accommodate as much as possible. For that, let me take any questions you have. Okay, we have no questions. Either it was good and clear, or you didn't understand anything, or it was not interesting. You see, we don't have enough data. That's too late to ask you that question because I don't have this poll, so I will just have to guess and maybe think about it for the next webinar. There was a question there that was probably answered um, during the webinar. I will repeat it. Could you please clarify when you talk about metrics, you mean KPI or something different? I thought I spoke about metrics on more high level. KPIs are definitely one of the metrics, uh, but I think not really. So yeah, I guess I did answer this question throughout the webinar. We do have a couple of minutes more. If you have any questions, fire away. And otherwise, I will thank you for being here. Remind you that the recording of the webinar you can find on JFrog YouTube page right now, right once we're done, or you can wait a couple of days and get a link in the follow-up email that we will send. Thank you very much for the interest in our future webinars. I see the results all over the board. It's actually most of the topics are of an interest, and we will try to do more of everything. And here's another comment. Let's talk about that. Kinbana has an interesting new tool, Canvas, for visualizing log data. Let the data speak. Perfect. That's exactly that, Michael. Thank you very much for this comment. This is it. Logs are a tremendous, obviously, source of engineering data that we do want to realize and analyze, and having instead of looking through the logs and searching through the logs, having a dashboard, product dashboard in Kinbana that is actually let the data speak is one of the elevation steps. Next step will be integrating it in even bigger picture, and that will be a runtime behavior of an application. Also very, very, very important. I guess that will require a dashboard of runtime operations that will include not only logs, but also stuff like how do you call it, monitoring, right, and alerts and observability, which logs is obviously one of the pillars of observability. But that's another webinar that we very well, sorry, might do as well. So with that, thank you very much for coming. Expect the recording. Feel free, obviously, to share it, and bye bye.